This video will give examples of how to do integrals with trig. Our first integral involves a case with powers of sine and cosine. Remember, our rule said that whichever power is odd, then you're going to strip out one of them. So in this case, we have sine cubed x, that's to an odd power. So we're going to strip out a power of sine. Now we're going to convert our sine squared into a cosine squared using a trig identity. And then multiply out, so cosine to the 6th x minus cosine to the 8th x. All of that multiplied by sine x dx. At this point, we can just say u equals cosine x, du equals negative sine x dx. So our integral becomes the integral of u to the 6th minus u to the 8th times negative du. So that's 1/7. I'm going to just go ahead and take out the negative sign. U to the 7th plus 1/9 u to the 9th. And then we can substitute in our value for u again, giving us negative 1/7 cosine to the 7th x plus 1/9 cosine to the 9th x plus c for our final answer. Here again we have an integral involving powers of sine and cosine, but unfortunately here we don't have anything that has an odd power, so we're just going to have to see what we can do about this. One thing we can try is to take out the squares so that this is sine times cosine x squared dx. Then we can use our double angle identity to rewrite this part as 1/2 sine 2x squared dx, or 1/4 sine squared 2x dx. At this point, we will recall the trig identity that says sine squared theta equals 1 minus cosine 2 theta over 2. So we can apply that here, rewriting our integral as 1/4 times 1 minus cosine 2 times 2x over 2 dx, which simplified is 1/8 times 1 minus cosine 4x dx. And from here we can just integrate, because that'll just be 1/8 minus 1/8 cosine 4x dx. So 1/8 x minus 1 over 32 sine of 4x plus c is our final answer. This integral is going to involve a trig substitution. So note that we have something in the form x squared minus a squared. What you can do is draw our little right triangle. Our hypotenuse will be 5x, one of the legs will be 2, and so that leaves our other leg as 25x squared minus 4. Now we'll label theta. Notice that the cosine of theta equals the square root of 25x squared minus 4 over 5x, which is almost exactly what we're integrating. In fact, if we just multiply both sides by 5, then we do get our integrand. Now we just need to put dx in terms of d theta. Notice from our triangle that we have the sine of theta equals 2 over 5x. So that gives us x equals 2 over 5 sine theta. Now taking the derivative, we get dx equals 2/5 times sine to the negative 2 theta times negative 1 by the power rule, and then the derivative of sine is cosine theta. Now let's plug in what we have to our integral. This part can be replaced by a 5 cosine theta, and then for dx we'll write in a negative 2/5 times sine to the power of negative 2 times a cosine d theta. So now that gives us the integral of negative 2 cosine squared theta over sine squared theta d theta. From here, we have powers of sine and cosine again, except that both of them are even. So I'm just going to take out the negative 2, replace cosine squared with sine squared on top. And what this allows me to do is break my integral up into two parts. Now, we should have memorized that the derivative of cotangent is negative cosecant squared, which is what we have here. So that tells us that we have negative 2 times negative cotangent theta minus theta plus c, or 2 cotangent theta plus 2 theta plus c. Now, using our answer and then the information relating x and theta that we've already found, we can put this answer in terms of x. So 2 cotangent theta, as you can tell from the diagram, is equal to 2 times the square root of 25x squared minus 4 over 2 plus 2 times, and theta is equal to the inverse sine of 2 over 5x. And our 2's will cancel out to give us a full answer of 25x squared minus 4 plus 2 inverse sine of 2/5 over x plus c.